We're starting a new unit today, and it's on acute triangle trigonometry is what it's called. This is a unit on trig. So today actually we're going to do two lessons because they're quite short. We're going to talk about exploring side angle relationships and acute triangles. That's a triangle that all three angles are less than 90 degrees. And we're also going to learn about something today called the sine law. Okay? So our focus is to explore the relationship between the side lengths and the sine of their opposite angles. And in what we discover doing that, we're actually going to discover the sine law and learn how we can use that to find unknown angle measures and unknown side lengths in triangles. Now last year in grade 10 you did learn the primary trig ratios. You learned about sine, cosine, and tangent. And you learn how to determine side lengths and angle measures in right angle triangles, okay? That's the key. Sine, cosine, and tangent have to be used in right angle triangles, triangles that have one 90-degree corner, like this, okay? You learned that sine was opposite over hypotenuse, and if you remember SOHCAHTOA, so sine equals opposite over hypotenuse. So ka is cosine equals adjacent over hypotenuse, and toa, tangent equals opposite over adjacent. Okay. In this lesson, we're actually going to explore the relationships between each side in an acute triangle. That's a triangle where all of the three angles are less than 90 degrees. So the relationship between the sides and the sine of their opposite angles. Okay, so here is a triangle with angles A, B, and C marked on it. And what this says is sides A, B, and C are opposite their respective angles. Now what that means is when we label the angles in a triangle, we label them with uppercase capital letters. When we label the sides, the corresponding sides, they're actually labeled with lowercase letters, and they will be the side that is directly across from the angle. So if you were standing at angle A here, and you shot an arrow directly across, this would be side A, and that's denoted with a small lowercase a. Okay. Same thing with side B would be directly across from angle B, again with a small lowercase b. And side C would be directly across from angle C. Again, a lowercase c. Shows that it's a side length and not an angle length. Okay? So for each of these acute triangles below, we're going to write two expressions for the height of each triangle. And then we're going to use our expressions to create equivalent ratios. Okay? So what that means is I'm going to draw a line perpendicular to the line segment AC at the bottom here, okay? So straight down from B, the height of the triangle. And when I do that, I've created a right angle, okay? Now I'm also going to label the side lengths on this triangle. So the side that's directly across from angle B would be side B. The side that's directly across from angle A would be side A. The side that's directly across from angle C would be side C. Okay? Now this, of course, perpendicular line that I've drawn, this is the height of this triangle. Okay, so we're going to see if we can use what we know about the sine ratio to come up with an equivalent ratios. So we know that sine is opposite over hypotenuse. Now, just to refresh your memories, when we're talking about sides that are opposite and hypotenuse, we need to make sure we understand what those terms mean. Okay, so if I'm talking about angle A here, okay, you have to imagine that you are sitting right here in this corner. If you shoot an arrow directly from there, the side that you're going to hit with that arrow is the side opposite. Okay? The hypotenuse is always, always, always the longest side, and it is the side that is directly across from the right angle. We have a right angle on that side as well. So it's always the longest side, this one, and it's always directly across from the right angle. Okay, so C would be our hypotenuse. So sine of angle A, okay, if you were standing right here in angle A's corner, it would be opposite, which is H, over hypotenuse, which is C. Okay, now if I just do a little bit of algebra and rearrange this equation by multiplying both sides by C, so multiply this side by C and multiply this side by C, these two C's actually are going to cancel each other out, and I'm going to be left with C times sine A is going to equal H. So C times sine A equals H. Okay, everybody see where we got that from? Okay, we just multiplied both sides by C, and that's what we ended up with. Okay, now let's see if we can use the sine ratio and go from angle C this time. So we're going to do a whole other one. So maybe I'll switch to a different color. If you have a different color, it might be a good idea to switch so that you can see these and not get mixed up. This is a new one, so we're doing sine again, but this time sine of angle C. And that's going to again be opposite over hypotenuse. So here's angle C, so opposite is H over hypotenuse, which is A. Again, if I just rearrange this by doing algebra, I'm going to multiply both sides this time by A. So I'm going to be left with A sine C, just means A times sine C, equals H, because once again, this will cancel this, right? Okay, now I have two statements. Look at these two statements. C sine A equals H, and A sine C equals H. Well, if those both equal H, then really I can say they equal each other through substitution, right? So I can say in that case, C times sine A equals, or is the same thing as, A times sine C. They both equal H, so they must equal each other, okay? This is my final statement, my conclusion, so I'm going to say, therefore, C sine A, in other words, side length C times the sine of A is the same thing as side length A times the sine of C. Okay? Are you seeing a bit of a pattern there? Hopefully you are. Okay? Let's have a look at this next triangle and do the same thing with it. This time we have triangle RST. I'm going to do the same thing again. I'm going to draw a right angle here. I'm going to mark my square corners. I've got one there and one there, obviously. This again, this is the height of my triangle. I'm going to also label that the side directly across from angle T is side T. The side directly across from angle R is side R. And the side directly across from angle S is side S. Okay, and now I can use my trig functions to fill in the sine of t. Sine t. So imagine that you are standing right here. Sine is opposite over hypotenuse. So we've got opposite, which is h, over hypotenuse, which is the longest side directly across from your right angle. That's r. So sine t equals h over r this time. Again, we're going to rearrange this a little bit just by multiplying both sides by r. When I do that, I have hr over r, so r's will cancel out, and I'm left with r sine t, or r times the sine of t, equals h. Okay. Then I'm going to do the same thing now with the other angle. I'm going to figure out sine of r. And so imagine now that you're standing in this corner, opposite is h, over hypotenuse is t. Again, a little fancy algebra. multiply this side by t and this side by t. Now I have ht over t, so my t's will cancel each other out. And on this side I'm going to have t times the sine of r is equal to h. And if I have r times sine t is equal to h, and t times sine r is also equal to h, then what that ultimately means is r times the sine of t equals, or is the same thing as, t times the sine of r. Okay, interesting. Side length r times the sine of angle t equals side length t times the sine of r. Very similar to what we discovered right here. Okay, what you have just discovered is actually called the sine law. Flip over your page, and we're going to fill that in on the blank right here. The relationship you've discovered is called the sine law. And this can be used to determine any unknown side lengths or angle measures in acute triangles. So now, instead of having to always work from a right angle triangle, we can use the sine law if we have angles that are not right angle triangles. Okay? So in this box here, we're going to write what a sine law really looks like. The sine law is side A divided by the sine of angle A, make sure you use a capital A for that to show that it's an angle, is the same thing as side B divided by the sine of angle B, which is also the same thing as side C divided by the sine of angle C. Okay, now you wouldn't necessarily use all three parts of this equation. If you were trying to find an unknown side length or an unknown angle, you would just use A divided by sine A equals B divided by sine B, or you might use just A divided by sine A equals C divided by sine C. Okay, so you'll just use pieces of it. You just need two of those ratios in order to use it. And which two you use will just depend on what information you're given in the question. Okay, so I think as we do a few examples, you'll understand what I mean by that. Let's use our highlighters. Grab your highlighter and just highlight this box, because this sine law is going to be very, very important. Okay, label this the sine law. All right, I'm going to just keep that here at the top of the page so that we can see it. Example 1 says determine the unknown side lengths for each triangle to the nearest tenth. And it also says whenever you're dealing with degrees and trying to figure out angle measures, you need to make sure your calculator is in degree mode. And what I mean by that is, here's our calculator. When you go into, see this button right beside the second, the yellow second key says mode? Click on that. Right now my calculator has radian highlighted. That means my calculator is measuring in radian mode. You're going to learn about that in Math 30 next year, but we need to be in degree mode. So you just toggle down to that and then toggle across till degree is flashing and hit enter so that degree is flashing. Once you do that, then your calculator will be in degree mode, okay? And then you'll be able to figure out angle measures. There's two ways to measure an angle. The other is called radian mode, and it will give you some pretty funny looking answers that hopefully you would recognize as impossible situations and realize that you're not in degree mode. But just whenever you're working with degrees, just double check on your calculator by going into mode. Make sure that you are in degree mode, okay? Okay, so we have two triangles here. This triangle ABC, we've got angle B and angle C given. We've also got side length B given. That's the 7 degrees, or 7 down here, okay? We don't know angle, or side C, and we don't know side A, okay? We have to figure out the unknown side lengths. So that means we're going to need to determine what C is as well as what A is. Okay? So we'll use bits and pieces, two parts of this sine law in order to figure that out. Okay? So what you do is you start with the information you are given, where you have both a side length and an angle measure. Okay? So there is only one case of that. That is angle B and side B we have. Okay, so that's the one we're going to start with. B, side length B, divided by the sine of angle B is going to be equal to, well, let's start with this. We want to figure out C. So this is side C and is divided by the sine of angle C. Okay, so you can see how we're not even going to use A divided by sine A, because the information that we're given lends itself to using B and C. Okay, all right, so side B is 7 divided by sine of B. Sine of B is sine 35 degrees, isn't it? That's what angle B is. Equals side C, which is the unknown, divided by the sine of 105 degrees. Okay, now I'm going to show you a little trick that you can use when you have one ratio equals to another ratio. In other words, you have one fraction on the left and you have one fraction on the right. The easiest way to figure that out is to look at the information that you have diagonally this way, and we're going to multiply those two together, so 7 times sine of 105, and then we're going to divide by this other one, sine 35 degrees. Okay, so on your calculator, you would do 7 times sine of 105 degrees. Make sure you close your bracket and hit enter, and then divide that by sine 35 degrees. And close your bracket and hit enter. And that will give you 11.788. And because this is a side length, it's told us to round it to the nearest tenth. So that tells us that C is actually 11.8 if we rounded it to the nearest tenth. Okay, we don't know what units we're using because it hasn't told us if this is centimeters or meters. Most questions would. Okay, pretty simple to use, isn't it? Let's try another one with this other triangle where we're given this time two angles, one side, and we're trying to find the unknown side, which in this case is X. That tells me that this must be angle X if this is side X, because it's directly across. Okay, I also am going to label maybe this one as Y then. This will be side Y, XY, and we'll call this one Z. Okay? Okay, so we're going to do the pieces of information that we have where we have one angle measure and one side length across from each other are Y. So we're going to do side Y divided by sine of Y equals, and the other one we need to figure out is our X. So we've got side X over sine of X. Okay, let's fill in what we know to be true. Y is 10 centimeters over sine of 63 degrees, and that's going to equal X, which is our unknown, over the sine of 49 degrees. Okay. And again, the easiest way to do this when you have a fraction on one side of the equal sign and a fraction on the other side of the equal sign is look for the two pieces of information directly diagonal from each other, multiply those together, divide by the other one. Okay, so we're going to multiply 10 times the sine of 49 degrees. Make sure you're plugging this into your calculator as well as at the same time I am. 10 times sine 49 That equals 7.547. Now divide that by sine 63 degrees. And hit enter. And that gives you the side you're looking for, which in this case was x, is to 1 decimal place 8 point, would that 4 stay a 4 or round up to a 5? It would round up to a 5 because it's followed by a 7. Okay, if it has the number after it is 5 or greater, make sure you round this number up. Okay, and this is measuring again in centimeters. So side x is 8.5 centimeters long. Okay, we've got one more example on the other page to try. Okay, this time it says determine the unknown angles for each triangle. And when you're dealing with angles, you find them to the nearest degree, to the nearest whole degree, no decimal places. When it's side lengths, it's usually 1 decimal place. Angle measures, it's just to the nearest degree. Okay, so it's exactly the same thing as before. The two pieces of information we're going to start with are the two where we have an angle measure and we have a side measure across from each other. So in this case, it will be A over sine A equal to, and we need to find the other two angle measures, both of them. But right now we only have one piece of information, and that's the 16. That's side B, so it's across from angle B. So we're going to go B over sine B. Okay, let's fill in the information we know. So A is 27 over the sine of 95 degrees. And that's equal to B, which is 16, over sine B. That's the unknown. Okay, now again, this time the two pieces of information I have that are diagonal to each other are those two, and we're going to be dividing by 27. Okay. Now, that's going to give me sine B. That's not going to give me what angle B is. That'll give me the sine of B. So I'm just going to write that out longhand. Sine of B is going to be sine 95 degrees times 16. And then we're going to divide it by 27. Okay? That doesn't give me what I want. This gives me sine B. I need angle B. So if this is going to give me some decimal that is the sine of B. To figure out what B is, I need to do the inverse sine. So I write that this way. I say, so angle B equals the inverse sine of this whole thing here, which is sine 95 degrees times 16, all divided by 27. Okay, that's going to give me angle B. So let's plug that into our calculator so you can see how to do that. Please make sure that you plug this in while I am, okay? So we're going to go, oops, I didn't do the inverse sine, right? This is supposed to be sine to the -1 inverse. Okay? So on your calculator, you'll see that you have that sine to the -1. It's the yellow writing above the sine key. So that means you're going to need your second function of sine, and that gives you the inverse sine. Okay, then it automatically gives you a bracket. So we're going to go now inside the bracket, sine 95, and then close that bracket, times 16, and then you're going to go divided by 27, and then remember to close the final bracket. Okay, when you hit enter, you get 36.18. Because this is angle measure, we're taking it to the nearest whole number, so that would be angle B is 36 degrees. Okay. Not too hard, pretty straightforward. Let's try the next one, and it's very similar to this one. Okay, so we've got an angle or triangle PQR this time, and we're going to start obviously with Q, and side Q is across from it, so that's the information we have. So we're going to go Q divided by the sine of angle Q equals, let's see, the piece of information we have is side R over the sine of R. Okay, so we have Q, which is 28, divided by the sine of angle Q, which is 39 degrees. And that's going to be equal to R, which is 41, over the sine of R. Okay, this is the piece of information I'm going to multiply together. This is what I'm going to divide by. And that is going to give me sine R, right? Okay, so that means sine R equals, put brackets.
Alexa, dude, may I place my keys back? Can you bring my keys back to the front, please, Alexis?
That's just for your comic relief. Sine 39 degrees times 41, all divided by 28. That gives you sine of R. So in order to figure out angle R, you're going to do the inverse sine of that whole thing. So sine 39 degrees times 41, all divided by 28. Okay, so angle R is. Okay, take a minute to plug this into your calculator. So we need the second function of sine to get the inverse sine of the bracket, sine 39, close that bracket, times 41, divided by 28. And close that final bracket, hit enter. Angle R is 67 degrees. Okay, so that's all there is to it. The sine law is fairly simple to use. You just use whichever section of it you have given the information to be able to use. Your assignment, you can see at the bottom of the page there, is page 138, questions 1 to 4, and number 6 and 7. And you have the remainder of this class period to work on that now.